Okay, guys, we are looking at section 7.4. It's on page 207 in the Student Journal. And we are actually going to wait on this. We're going to go down here to the core concepts. What we're working on today is adding and subtracting rational expressions. Remember, those rational expressions are just fractions that have variables in them. If we're adding or subtracting and we have the same denominator, it's really easy. We just add the numerator and it all goes over C. Or we subtract the numerator. So here we have a common denominator. So what would this answer be? Negative what? Negative 5x over 2. Because when we're subtracting with fractions, we subtract the numerator and the denominator stays the same. So that would be the answer there. Okay, so what about if we're adding or subtracting and we don't have the same denominators? Okay, so we're going to start off with a fairly easy problem when we do not have the same denominators. Well, just think if this had been 1/3 minus 1/2. We'd have to get a common denominator. What would that common denominator be? 6. So I would need to have a 6 here, and I would need to have a 6 here to be able to subtract. So what would I multiply 3 by to get 6? So I'm going to have to multiply this by 2 over 2, which is just 1. And this is going to have to get multiplied by 3 over 3. I'm also, though, going to have to multiply by this negative. Don't forget to multiply by the negative. What I always do is I like to just make it addition and take care of the negative now. But I'll keep it as subtraction, actually, for this problem, and then I'll show you later how to do that. When I distribute this, I'm going to get 6x plus 4. When I distribute this, I'm going to get 6x minus 3y. Now this should have a y on it. All right, so now, though, I'm subtracting. When you're subtracting, you can just change the signs and add. So instead of thinking of it like this, I'm going to change this to a plus, which means this is now going to be a negative and this is now going to be a positive when I do that. So now I have common denominators. So what's 6x plus negative 6x? And what's 4y plus 3y? So this would be 7y over 6. So everybody's done adding fractions when we don't have the same denominator. It's just now that we're throwing in the variables. All right, so now instead of going to the top here, we're going to do this later. We're going to come down here to the extra practice. And I want you guys to do number 1 on your own. Jesse, what is it?
It would be negative 4 over x minus 1.
Right. That's all we have to do. All right, number 2, we have a common denominator, so we're just going to add the numerator. So it's 6x plus 24. But we now have to check to see if we can do something like we did on last night's homework. This is now a rational expression. Can I do any factoring and simplify this? What can I factor out of the numerator? 6, and then I would have x plus 4. And in the denominator, I have x plus 4. So now I could cancel these out. And the answer is just 6 for this. But I would want to make that stipulation that x cannot equal negative 4. See, back at the beginning, if I plug in negative 4, I would get negative 24 plus 24 is 0. Negative 4 minus 4, or sorry, negative 4 plus 4 is 0. So see how I get 0 over 0? But what do I get now? The answer is always just what? 6. So that's why I'd have to make that requirement there. Now, I'm not even sure they're going to make you do that on this lesson, but if they do, make sure that you do it. All right, so now I want you guys to try number 3. Make sure you get it factored completely at the end. How'd you do? Did you get it right? Any questions?
So does that mean 2x equals x?
No, 2x is what this simplifies down to.
Oh, okay.
Another name for this would be just 2x.
All right.
So if I were now trying to evaluate, like when x is 1, the answer would just be 2. That's a lot easier than plugging in here.
Yeah.
But the problem is this does not work if x is 7, because 2 times 7 is 14. But if I plug in 7 here, I'm not going to get that same answer. That's why I have to say that. But I don't even think they make you say that. We'll see when you start on the big ideas online. All right, let's go over here now. Okay. Everybody in my first period class had a bit of trouble with this, what a least common multiple is. I'm going to show you just with numbers. On the other page, if we had 2 and 3, what did we use for the common denominator? So 6 is what we call that least common multiple. It's also going to be that common denominator. Least common multiple means the same thing as the common denominator. So what if we had denominators of 9x cubed and 3x squared minus 21x, and we had to figure out what would we use for the common denominator? Here's the way we want to think of that. This is already a bunch of factors. This one I want to rewrite as factors. So I'm going to factor out a 3x, and I would be left with x minus 7. So now, if I have a 9x cubed and a 3x, what would I want to use for those two as the common denominator? In other words, I need something that they can both be divided into evenly. If I just use 9x cubed, can 9x cubed be divided by 9x cubed? Can 9x cubed be divided by 3x? Yes. So I'm going to just use 9x cubed and that would work. It's just like back here. I had to think what would be a number that both of these divide into evenly. It's the same thought process. So I've taken care of this and this. But what about the x minus 7? It has to be divided evenly too. So what this could be divided evenly into is x minus 7. That would be the least common multiple. All right? Let's look at another one. For this one, here's our first factor. We're just going to think of it, it's x plus 5. This is my other factor. I need to factor it completely. So I put 2x and x. And then what numbers would multiply to be 5? 5 and 1, and I need to get an 11. So how am I going to do it? Good. All right, so now, this would be like one of my denominators, and this is the other denominator, and I need to think what it is that this can divide into and this can divide into. So what am I going to have to use? X plus 5 is going to have to be used, right? For sure. That takes care of both of these. What else would I have to use? Tori?
2x plus 1.
Right. That would be what we would need to use to have a common denominator. All right, you guys try the next one now. For these two, what would the common denominator need to be? You might think they know what it would be. Justin?
Would be x plus 3, x plus 2, x minus 2.
You got it. That would have to be our common denominator. So check. This one has to be in there. This one has to be in there. This one must be in there. And that one is already in there. So we're good. That would be the common denominator. If we had this and this as a denominator, that's what we would use for the common denominator. Okay? All right, let's do some problems now. So, what would be the common denominator that we would need here for 2x and a 5x?
X.
Say it again.
X.
Just x? Can 2x go into x?
Oh, no.
Okay, so I need a denominator that both of these can be divided into. Tori? 10x. 10x would have to be the common denominator. Okay, so think about this. 2x times what would give us the 10x? So we have to multiply this by 5 on bottom, so 5 on top. So that's going to give us 15. What do we have to multiply this by? 5x times what would give us 10x? So times 2. So that's going to give us 22. Now we have a common denominator. Tommy, what's the answer going to be then? Good. Questions? All right, let's look at the next one. Be thinking about it. What would be the common denominator that would be needed? Justin and Tori, I need somebody new to tell me the common denominator. Frank?
X squared plus 6 minus 16.
Okay, close, but I don't want it in that form. I just want it in that basic form, in the factored form.
X minus 2 times x plus 8.
Good. No need to make it more complicated. We're just going to keep it in that factored form. All right, so what factor is this one missing? X plus 8. So I'd have to multiply it by x plus 8 on top and x plus 8 on bottom. All right. So that's 15x plus 120. All right, what about the second one? What are we going to multiply that by? X plus 2, good. So I'm going to multiply by, or x minus 2 rather. X minus 2 on top, x minus 2 on bottom. So distribute that through, so it's going to be plus 3x minus 6. And now you just need to combine all your like terms. So 18x plus 114. Now I might want to check if that can be factored. I don't know what 114 divided by 18 is. Nope. See, that's how I tried it. It's not even, so therefore it cannot be factored any further. So that's great. We're just going to leave it as is. Okay? Yeah, just. You could, but it's not going to cancel out with anything anyway. So that's why I'm not really too concerned about it. If I could, even if I do take out a 2, it would be 9x plus, what is that, 57? So that's not going to have a common factor. I don't think there's any way I'm going to get a common factor with it. So I'm just going to leave it. Now, if I had taken out an 18 and this had been x plus 8, then I would want to do that. Okay? All right, let's go ahead and try number 10 now. So we want to have everything completely factored in the denominator, just the denominator. So that's factored, leave it alone. This needs to be factored. Go ahead and factor that. You should already know what one of the factors is going to be. Taylor, do you know how it factors? That can't be right because I have to get something times something has to give me 2x squared. So it'd have to be 2x and x. Anybody think they can go from there? Ronnie?
So the 1 and 3 made 3, obviously, and so it would be 2x plus 1 times 4.
Good. Okay, see how that works? I check it. 2x squared, I got it. Negative 6x plus 1x, that gives me that. Negative 3, that gives me that. Okay, so that's good. Now look at this, guys. Here's one of our terms. Here's the other term. For those two terms, what common denominator are we going to need to use? Justin?
X minus 3. Well, no, 2x plus 1, but then we'll have to use the x minus 3.
Right. We have to use both of those, don't we? Because this has to be divided into it evenly, and this has to be divided into it evenly. So what is this term missing? X minus 3. So I'm going to multiply this by x minus 3. Distribute it. 3x squared minus 9x. What does this one have to get multiplied by? Really? Doesn't have to get multiplied by anything, does it? So what am I going to put next? Plus 10. Now, I should check to see if this can factor further, because maybe it could, but here's the way you do that. Multiply the first and last, and you get 30. Are there factors of 30, in other words, numbers that multiply to be 30 that add to be 9? Numbers that multiply to be 30, 6 and 5, 2 and 15, 3 and 10. Do any of those add to be 9? No. So this is our answer. We don't want to do anything else with it. All right, last one. You guys get it started on your own. All right, I know you're not finished, but let's kind of finish it together, okay? So here's term number 1 in this box. What is that term missing? What factor? X plus 1. So we're going to have to multiply the top and the bottom by x plus 1. Okay, what do I get if I multiply that top by x plus 1? Good. Now, whenever I have subtraction, I just like to make it a plus a negative 2. I think it's easier that way. Make it plus the negative. And then what is this one missing, everybody? X minus 7. So that's going to give us what? Negative 2x, then what? Plus 14. Good. Now what about this last term? What is it missing?
Nothing.
Nothing. So what am I going to put? Careful.
Minus 3x.
That's why I like to do this at the very beginning, so I don't mess that up. Okay, minus 8x. All right, so simplifying this then, we're going to have x squared minus 9x plus 14. So we hope we're finished, but we have to think back to what we did last night. Are there numbers that multiply to be 14 that add to be 9? 7 and 2, right? So we're going to have to factor that. X minus 7, x minus 2. So therefore, these can cancel out. This would be the simplified version. And like I said, I'm not sure if our book's going to make us, but we would say this is this is equivalent to that, except for when x equals 7. So we would say x not equal to 7. This is the same thing. Tommy.
So how come sometimes you have to multiply the numerator by the denominator?
Because it's what this is missing. Like if we go back and we do let's just do an easy problem. like 1/2 plus 1/3. What we do is we say the common denominator would be 6, and we say 2 times what would give us 6? Well, that's times 3, so that's why I have to multiply by 3. Down here it's the same kind of thing. This is our common denominator. So this one is missing the x plus 1 that's in our common denominator. This one is not missing anything. See, if I had you do 1/2 plus 1/4, what's our common denominator now? You don't have to go to 8. 4, right? Okay, so then what's this one missing? 2, so I have to multiply that by 2. What's this one missing? It's already the same, so I don't have to multiply by anything. It's that same concept. All right? Okay, any questions over that? All right, that's the first part of 7.4. We're going to stop there for a minute.